serve as a warm-up for questions 2 and 3. So in question 2, you see this image which I have displayed on the screen here. And they give you kind of an explanation, and they say, in order to show why line segment DE is a segment bisector of AB, we can begin by taking the following steps. And you can see they've drawn in red these line segments. So this is something they've added after the fact. We've got line segment AE, BE, AD, and BD, all these 4 line segments in red. And then they've labeled this point F, which is the intersection of line segment AB and line segment ED. Now they say, if we can show that these 2 triangles, the triangle AEF right here, AEF, if I can show that that triangle is congruent to this other triangle BEF right here, then that's going to help us achieve our overall goal, which is to show that line segment DE is a segment bisector of AB. So, think about all that information for a moment, make sure you understand it. And then keeping that in mind, the question is, why do we use the circle with center through point tool to draw one circle and the compass tool to draw the other? What was the point of that? So think about the question, think about those tools and what they do, and think about the information they gave us. So right off the bat, they drew in those line segments. So they must have had a plan. So in what way did drawing the image, drawing the circles, and using the compass tool influence what we can claim about these line segments? And think about maybe the measure of these line segments. Why were those tools important? Okay. Now let's talk about question 3. So in question 3, you are asked to complete a proof. And you're told that the table, which here is set up like a 2-column proof, explains why line segment DE is a segment bisector of AB. And by definition of bisector, we know that that means that line segment AB, or rather line segment DE, cuts line segment AB into 2 congruent segments. So we have to fill in the blanks here. So I'm not going to give you the answers, but I'm going to review this proof with you and hopefully kind of help you fill in the blanks. So the first thing that they go into is they say that AE is equal to AD is equal to BD is equal to BE. And we know this because of the way this image was drawn. 2 circles are drawn with the same radius. Next, they claim that these line segments must all be congruent to one another, and this is a move we're pretty familiar with by now, right? Pretty standard procedure. If line segments are of equal measure, then they are congruent. So they claim that, and I'm even going to, as you guys know, I like to kind of note stuff on the image as I go. So I know that AE, AD, BD, and BE are all congruent to one another. Next, they say that DE is congruent to itself. So this line segment, and let me highlight that in a different color. This line segment DE is congruent to itself. What's the reason for that? What is the theorem, the postulate, the definition, the rule that tells me that something is congruent to itself? I'm not going to give that one away because we've reviewed it a couple times and you should have it pretty well ingrained in your head or in your notes by now. So how do we know that a line segment is congruent to itself? Find the definition, postulate, rule, or theorem that proves that. Okay, so now take a look at where we're at in this proof. So consider that we have now just established, and remember the triangles that we have in mind, triangle AEF and BEF, right? Where we're at, we've already proven that line segment AE and BE are congruent, and we know that line segment DE is congruent to itself. And now they're claiming triangle AED and BED are congruent. AED and BED are congruent. So this isn't the same triangle we had talked about in the last slide, right? This is a slightly different one. So here is AED, and I won't fill it in all the way. That's AED, that larger triangle. And this is BED, right? This is BED. And we're able to claim that those are congruent. Why? What's the name of the postulate or theorem that allows me to state that? So just think about what information we use to prove it. I know that AE, BE, BD, AD are all congruent, and I know that ED is congruent to itself. So what theorem deals with proving congruence of triangles based on their sides being congruent? What is that called? And that's what you'll fill in for B. Next, they claim that angle AED is congruent to BED. That AED right here, is congruent to BED right here. We know that because those are corresponding parts or corresponding angles of congruent triangles. So if the angles are from congruent triangles and they are corresponding angles, they must be congruent. And I know that, again, by the definition of congruent triangles. Next, we claim that line segment EF is congruent to line segment EF. And that's this shorter, and I'll highlight it again, that's this shorter line segment. So it's just from here to here, line segment EF. We're claiming that EF is congruent to EF. And how do we know that? Well, hopefully you've already looked up the answer for A. This is the same thing that reappeared up here, right? So what postulate, theorem, or thing allows us to claim that a line segment is